Hello, this is Sam Switchtrack here with the Charon View channel, and this time we want to talk about Little Railroad Chapter 2, Control Systems. Also, we'd like to thank all of our viewers, and especially those who have subscribed to our channel. Okay, we have a lot of ground to cover, so let's get to it. Okay, what we want to talk about this time for operations is the basis. First is it's an MTH Protosound 1 based control system. Now that one does not include locomotives with battery switches. I'd call them Protosound 0. So yeah, it's all Protosound 1 based. Now the mode we use is forward, neutral, reverse, same as post-war Lionel. You interrupt the power, go to neutral, interrupt, go to reverse, interrupt, neutral, and so on. We always use that. We do not lock locomotive in a particular direction or in neutral. Now it is a 3-rail O-scale layout, and because of that, there is no change in polarity as we go around through reversing loops. It always maintains the same polarity no matter what you do. So on this 6 switch track arrangement, you can see basically there's 6 reversing loops available. So it adds a lot to the operation of the railroad for switching. It's block running, and we'll show a diagram of the blocks in a few minutes. Okay, the controls, it's powered by basically 2 Lionel KW type transformers. Now if you're going to use them together on the layout, you have to phase them. And at some point we're going to do a video on wiring, and we'll talk about that more in detail. Our control panel hinges down for access. There's no lights for switch tracks. Switch position determined entirely by line side signals. And there's schematics available, relatively easy to change signal orientation, which has been done a number of times. Nothing else has been changed since the layout was built, just the signal orientation. So let's examine the control panel at this time. Here is the control panel in the normal operating position. I'm going to lower it down now, and I'll explain the controls at that point. It's made to be lowered so that it has more access for maintenance or changes to the wiring. Okay, this is the control panel. Now, these are the 2 KW transformers. I call this the A1 and this the B1. Now, on these KWs, sometimes if you try to run 2 trains with one of them and you move this, sometimes this other one moves or it changes a little bit, and kind of goofs up the operation. So what we do is we just use this side of each transformer for power. This side is not even hooked up. Down here is the block switches. There's 16 blocks, insulated track blocks. These are the switch controllers. Now I'm going to turn the panel on. And as you can see, no lights come on because the bulbs are all gone. We run switches entirely by line side signals. This resistor here is used to reduce voltage to the switch tracks. The idea being to run them at the lowest voltage possible and still have them switch. My understanding is it helps preserve some of the contacts inside. The lower the voltage, the longer they're going to operate. And so far there's been no problem with those switch tracks. On coupler tracks, there's 6 of them, and they're down. These are the controllers that we're using. Now, when you switch to this side, this is 1, 2, 3, 4, 5, 6. Okay, that's pretty much what we have for controls that's active right now. So I'm going to focus the camera on the top part of the control panel. The top part of the control panel looks like a complete mess, basically, because it is. However, there is some order and a confusion. Now, everything from the layout goes there, including switch tracks, track block power, uncoupler tracks, and signals. So, to facilitate making changes and to keep keep from going crazy, we made a wiring diagram when we wired it up. That's very easy to refer to and make the changes we want. And I've said before, the only changes we've made in the wiring really is the line side signal orientation. So, okay, that is the control panel. Now let's get back to our list of topics and move on. Okay, back to our topics list. Now we have the block layout, switch layout, and signal layout. So there's kind of a messy diagram prepared to show some of those details. This is a diagram of the layout with the track block numbers placed on there, as well as their how they're laid out, and the switch track numbers. So block 1, the switch track numbers are in circles. Now block number 1 runs from here, which is pretty much the legs of the switch track to the legs of switch track. 2 is this very long block that runs back over here. 3 is similar to 1, where it runs from legs of switch track to legs of switch track. 4 is a shorter block. It's not this short, but it's anyway, it's block number 4, and block number 5 goes from here to here. 6 goes from here to here. 7 is from here over to here. 8 goes from here over to here, and 9 is this piece of track. 10 is over here. 11 is another shorter block in here. Again, it's a little longer than that on the layout. 12 is in here. Then we have 13, 14, 15, 16, or 15 and 16, yeah. These were, on these dead-end tracks, these were laid out to well, parking of locomotives and turning them off. Okay, switch track numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I'll show some of these features on the layout, especially in this area, so there's to avoid some confusion there. Okay, I just want to talk a bit about blocks number 4 and block number 11. Now block number 11 runs from this point here and goes up to here. Now it's a short section of track to have as a block, but the allows the train that's either on here or here, if it's on the same transformer, to be run through, or it can be switched to accommodate either train and have the other train idling on one of the tracks. That's why it was necessary to put that one in. Block number 4 actually runs from here down over to here. And it's a similar idea. A train can be parked here on a different transformer, and then this yard can be worked from this track here. So other than that, I think it's pretty straightforward on the diagram, even though it's not the best diagram. So now let's talk about the signals. The signals are positioned so that they're all viewable from the operator's chair, which is where the camera's placed right now. I don't know if we'll be able to see all of them, but there's one over that way. It's signal switch number 2. They pretty much all signal leading into the switch track. So that's number 2. There's a signal bridge here, which is number 4 and number 5, and then there's a dwarf is number 1. And as we go around, there's one here for number 3. Let's keep going. There's one there for switches 1 and 2. There's a signal bridge there, an old Lionel one, for switches 7 and 8. And over here, we got a grouping of signals. This is 1 and 2, number 3, and number 6. Now what we're going to do, this signal is number 10, which is different from all the other ones because it's not a lead-in signal. Well, it's going to be changed. It's kind of quirky to have one of them pointing in a different direction. So there's a dwarf over by the Lionel signal bridge that we're going to change. It used to signal switch number 3. We're going to make it switch number 10 so that it blends in better with our control idea. Now, that's pretty much it for signals. So, it works great. We'll give a demonstration in just a few minutes. Okay, back to our list of topics. Again, wiring details to be discussed in a future video. That'll include how to get signals to operate with switch tracks. It's a little bit involved, but it's not bad, and we'll do that video at some point. Let's move on to motive power. Now, all units, including both A's and the B unit of ABA sets, are powered with sound. There's no more connecting cables in the ABA sets, and we don't have any dummy units at all. And we like to run up to 3 locomotives in a consist. If they don't operate that way, we usually move them on or repair them so that they will function that way. Now, we installed toggle switches because Sam Hongs was good enough to put places in the frames for that to turn on and off headlights. Some lights are simply unplugged because we'll never run them that way. And also the low idle sound is important. When we put a consist together, we make sure that when it goes into idle, if it's going to go into the low idle, all 3 units will do that. And they all have BCRs, and we usually allow about 3 minutes for them to charge up at 12 volts. Now, we'll discuss more about motive power in a later video. There's a lot more to it. So, well, let's watch a good 3-unit consist run. And, okay. Okay, this is our 3-unit consist. The lead locomotive is a GP30 by Mike's Train House and this Protosound, standard Protosound 1. The C628 is by Weaver, and it's been fitted with a QSI QS2 Plus sound system, which is compatible with Protosound 1. And this U25B is also by Weaver, and it's been fitted with a QS3000 sound system, which is also compatible. And let's take off. Okay, let's try some switching. And you always hope that you got it right. Well, we hope you understood this segment on control systems. Please tune in next time when we talk more about actually operating this little railroad. Thank you much and have a great day.